Singapore Mathematical Society and SMO Open Section Round 1 2019. We want to consider how to solve all problems of this exam. So let's see problem number 1. Find the largest positive integer k such that this fraction is always negative for all real values of x. So if you pay attention, the numerator is a quadratic function, negative x squared plus xk minus 400. Also, denominator is a quadratic function. So we know that uh, they shouldn't have root because, for example, if numerator has root, then we have 0 for some x's, and it says it's always negative. Also, because it is always negative, we know denominator shouldn't have any roots. And so at first we know that the discriminant here, we want to consider at first general idea, the discriminant here should be numerator should be less than 0 because it doesn't have any root. Also for denominator, and then we should pay attention also they should be always negative. Let's consider the solution of this problem. We know negative x squared plus xk minus 400 is positive. Let's consider for all, find the largest positive k is always negative for all real numbers. X squared minus k. So if we consider this function, oh sorry, we should correct it. It should be always negative because I will tell you. Because the function here opens up because a, the coefficient of x squared is 1 positive, and here it will be something like this because they shouldn't have a root. So it should be like this, it should be like this. So then if you divide them, always the answer is negative. The discriminant of this part will be what? K squared minus 4 times negative 1 minus 4ac, negative 400 less than 0. Discriminant, also discriminant of here, because they shouldn't have root. So here, b squared minus 4ac, 1 minus 4 times k minus 38 times 1, less than 0. From first one, k squared is less than negative, negative, plus, negative. To take it to the right hand side, it will be plus 1600. And from second part, for negative 4k, we take it to the right hand side. 1 plus 4 times 38. It will be 1. Yes, 152. So 153. So k is greater than 153 over 4. Here, absolute value of k is less than 40. The problem says find the largest positive integer k. So from here, k is less than or equal 39. From here, k is greater than 38 point something. And so the largest positive that satisfies both conditions is k equals 39. So if you place k 39, they don't have any roots. It is always negative because the sign here is negative. The coefficient of x squared, it is always positive. So because it is always the first one, always negative, always positive. So their division is always negative for k equals 39. Okay, problem number 2. As I said, if you had any problem with any other exam, it is not important how hard it is. Send message through my WhatsApp number here. Okay, so let's consider problem number 2. Among all the non-zero real numbers x, y, and z, satisfying x plus y plus z equals 0, find the largest possible value of this. This is an expression. So let's see how we can solve this problem. Here, if the problem says what? All the non-zero real numbers, x, y, and z. Because x, y, z, all of them are in the denominators, so they shouldn't be zero. Now, if I can say, replace y plus z with negative x because of this. X plus y plus z is 0. So y plus z is negative x if you take it to the right hand side. And if you multiply both sides by x, y, z, because they are non-zero, so on the problem says non-zero, and so if we multiply by negative x, let's see what we have. Can we say x is positive or no? Because we have this, it's also negative. So what should we do here? Let's see if we multiply. If x, y, z is positive, it will be okay. We can multiply both sides by x, y, and z. So it is for the case that what? We have, for example, 2 negative, 1 positive. But maybe we have what? Negative, positive, positive. Now, let's see. It says find the largest possible value of this. I want to say it is always less than or equal to 0. So suppose, let's consider at first the case at x, y, z is positive. So we multiply both sides by x, y, z. So here y, z cancel, x, y, z cancel y, z. We have x. Instead of y plus z, you can consider negative x. Then these things, also you do the same thing for other parts. Now let's see what we have. Negative x squared y squared. Also here we have negative y squared x squared. So negative 2x squared y squared. Similarly, we have negative 2x squared z squared, negative 2y squared z squared. Here we have x to the power of 4. Similarly, we have y to the power of 4 plus z to the power of 4. And it is exactly what? You can say it is x squared plus y squared minus z squared to the power of 4. And it will be what? For example, we have x to the 4, y to the 4, z to the 4. And 2x squared, y squared, we have what? We should have negative 2. So we consider negative 4x squared, y squared. For other parts, it's okay. Negative 2x squared, z squared. Negative 2y squared, z squared. And now it's equivalent that it is less than or equal to this. So let's see how we can prove it. It is equivalent that negative, we know what? If we replace z with x, we know x plus y plus z is 0. So z is negative x negative y. Because it is to the power of 2 squared, so you can consider that the squared is x plus y squared. So if you replace here the left hand side, x squared plus y squared negative x plus y squared, so you have what? X squared and plus y squared, they will be cancelled, and then you have negative 2x y and negative 2xy squared, so it will be 4. So because we multiplied by and we've reached equality, so you say you want to prove this, okay? You want to prove that this is 0. So it is not important to consider the sign. I solved these problems before, so sometimes we forget some parts. So if you had any summer camps, any And prestigious competition, want to prepare for any of them, as I said, you can call my WhatsApp number. It is also in the description. So we said they are equal, they are equal. So all of them, you can say this. Let me write like this. Why it is true, why it is true, why it's true. The last one is okay. So we wanted to prove equals 0, so we multiplied by x, y, z. X, y, z, so it is not important. Let's erase this condition. It is not important. It is always 0. So x, y, z, because x, y, z is not 0, you can say they are equivalent. That it equals 0. Inequality, because for example, 2 is not equal to 0, it is wrong. But if you multiply both sides by 0, 0 equals 0, so it is not equivalent. That's the reason we should consider that x, y, z is not 0, because the problem says all the non-zero real numbers x, y, z. So product of them x, y, z is not 0. So we proved always this term equals 0. So the largest possible value of this is also 0. So the answer is 0. Problem number 3. Assume that alpha is between 0 and pi over 2 and cos of alpha plus pi over 6 equals 4 over 5. Determine the smallest possible integer r such that 100 times sine 2 alpha plus pi over 12 is strictly less than r, and r is the smallest possible integer. So let's see how we can solve problem number 3. Let's scroll down a bit more. Okay, so here I say, okay, here I want to find 2 alpha plus pi over 12, and here I want alpha plus, I have alpha plus pi over 6, so I should find the relationship between them. So I consider this part equals beta, I change them to degree. Pi is 180 degrees, so pi over 6 is 30 degree, and pi over 12 is this over 2. Is 15. So we know alpha plus c, alpha plus 30 equals beta alpha plus here. Alpha plus 30 equals beta, we consider. So then we can say alpha equals beta minus 30. Now we want to reach 2 alpha plus 15 or other things. So you can also consider 2 alpha is what? 2 beta minus, multiply both sides by 2. Because we want to reach 2 alpha plus 15, so add 15 to both sides, it will be 2 alpha plus 15 equals 2 beta minus 60 plus 15 minus 45. Now, it will be 100 times sine 2 beta in terms of beta, 2 beta minus 45. So sine 2 beta minus 45, there is a formula that sine alpha plus beta equals. You should memorize this. Also, there are some other formulas, around less than 10 important formulas in trigonometry that you can be able to solve problems in round 1 and round 2. With that, also for geometry, we have around, I can say, 40 ideas and things that you will be able to solve round 1 and round 2. If you wanted to more explanation, send message to my WhatsApp number here. Now let's consider this part. Here sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. So if I apply this formula here, it will be sine 2 beta times cos negative 45, it will be root 2 over 2. Plus cos 2 beta sine this. Sine this is negative root 2 over 2 and negative here, cos 2 beta. So we've applied this formula here. Now, if we find sine 2 beta and cos 2 beta, then we can find sine 2 beta minus 45, and we can find this term. Sine 2 beta, there is a formula for a special case of this. Sine 2 beta or sine 2 alpha. 2 beta, if you consider alpha equals beta, it's 2 sine beta. Both of them will be sine beta cos beta. And also for cos, we have a formula that is important. It's cos alpha cos beta plus sine alpha minus sine alpha minus sine alpha sine beta. And if you consider alpha equals beta, it will be cos squared beta. Let me write here. Cos 2 beta will be cos squared beta minus sine squared beta. So here we know cos beta is 4 over 5. So we know cos squared plus sine squared is 1. So, and also alpha is between 0 and pi over 2 in the first quarter. So sine and cos will be positive. So sine will be also 1 minus 4 5 squared, which is 25 minus 16 over 25. It will be 9 over 25. If you consider square root, it will be 3 over 5. So sine 2 beta is 2 times sine cos. 4 over 5, 3 over 5. 2, 4, 8, 3. 24 over 25. Cos 2 beta is cos squared beta 4 over 5 squared, which will be 16 over 25. And then negative sine squared. 3 over 5 squared. Then we've got 9 over 25. This subtraction equals 7 over 25. Now, we can say 100 times sine this is root 2 over 2. Sine 2 beta is 24 over 25 minus cos 2 beta here is 7 over 25. We've replaced. And now we say, okay, 100 over 2 is 50, then over 25 here. It will be 2, so 2 root 2 times 17 is less than r. So r is greater than, you can take all things inside the square root. It will be 4 times 17 squared is 289. 4 times 2, 8. 8 times 2, 8, 9. And a square root of, if you multiply, we should find a square root of 2, 3, 1, 2. And a square root has a way to calculate, an easy way. If you wanted, I will tell you for this only problem. If you wanted to know exactly the algorithm and how to solve, also here you will understand. But if you wanted more explanation, feel free to send message to my WhatsApp number here. So 2, 3, 23, 12. You say from right, you consider 2 by 2, now 23 is left. So you say one way is to just consider, for example, 40 squared, 50 squared, then find what is near, but the easier way is 4, 4, 4, 16, 4, 7, 12, then 4 times 8. 80 what times what itself, same number you should place. For example, 89, no, 88, it must be near to 712, but less than that. 8, if you place 9 here, then it will be greater than this. If you place 8 here, yes, it will be this here. Okay, so it will be 48 point something because we have a remainder. So 48 times something, or the problem says is the smallest possible integer. So smallest possible integer that is greater than 48 point something is 49. Problem number 4, determine the number of integer solutions of the following inequality. This x minus 29 is strictly less than logarithm of x plus 2019 base 10. We will consider the solution. If you had problem with any exam in mathematics, it's not important. It doesn't matter how hard it is. Feel free to send a message to my WhatsApp number. So let's consider problem number 4 here. We know that if you consider the domain of logarithm, x plus 2019 must be greater than 0. So because it says the number of integer solutions. So here we know x is greater than negative 2019. So because x is integer, so x is strictly greater than negative 2018. Negative 2018, if you place here, the right hand side will be positive. Always it's logarithm of 10. Let's check, for example, for this part. Logarithm of 10, negative 2018 to 1. It equals what? It equals, we know 0, but if you wanted to know, you can say, okay, if we consider it is, for example, y, 10 to the power of y is 1, so y is 0, okay? So the right hand side is 0, the left hand side is negative, so that's okay. For example, if you want to consider the other parts, negative 2017, all of them logarithm will be positive, because if you consider the function, it will be this for 1, because all the things inside is 1 or greater than 1. Logarithm will be 10x, and it is x. All the right hand side will be non-negative left hand side until, let me tell you, until 2019. All of them will be okay, because if you place 2019 here is 0, but here is positive, because 2019, if you place, it will be 2 times that, it will be something like this. And for this problem, you should know a little about logarithm, the definitions, the diagram, then you can solve it easily. Now, let's check 2020, 2021, because after 2020, it will be positive. So, if you want to check, let me check, for example, 2022, 2023, we'll understand completely, and you check that 2020, 2021 is also correct. If you see how we prove 2022 is correct. So if I replace x with 2022, the left hand side will be 3, and the right hand side, if you add 2022 with 2019, it will be 4, 40, 41, and it's equivalent, because it is an ascending function. 10, it is equivalent. The 10 to the power of this is less than 10 to the power of here. 10 to the power of 3 is 1000. 10 to the power of this part is 40, 41. That's correct. But if you consider 2023, it will be 4, it will be this. If you raise the power of 10, if you raise 10 to the power of these two things, the left hand side will be 10,000, the right hand side 40, 42. It's right. And you can see if you add x by 1, the right hand side will be add by 1, but the left hand side will be multiplied by 10. So from here, we don't have any good numbers. So until 2022 is okay. So from negative 2018 to 1, 2018. From 1 to 2022, 2022 plus 1 for 0 is 40, 40 plus 1, 40, 41, the answer. Or you can say the last one, 2022 minus 2018, this formula plus 1. And it will be what? It will be 2022 plus 20. The last one minus first one, when you have consecutive integers and you want to count the number of them, it will be plus 2019, and it is exactly here. Again, 40, 41. Problem number 5, assume that negative 1, 0 is a point on the curve y equals ax squared plus bx plus c, where a, b, c are 3 fixed numbers not exceeding 1/2 if the inequality x less than or equal ax squared plus bx plus c less than or equal 1/2. X squared plus 1 holds for all real numbers x. What is the value of 2020 times a squared plus b squared minus c squared? Okay, so let's consider solution. Let me scroll down a bit more. Now, here it says for this part negative 1, 0. So if you replace x with negative 1 and y 0, then we have this equality. Y 0, 0 equals a negative 1 squared a plus b times negative 1 negative b plus c. So if you take negative b to the left hand side, b equals a plus c, and that's useful. I call it star, then we will use it. Also, we know abc are less than or equal 1/2. Now, here we have two inequalities that holds for all real numbers. So if we consider the first one and take x to the right hand side, Then we have quadratic function ax squared plus x 2 times b minus 1, or b minus 1 times x plus c is always greater than equal 0. Also, if we consider this one and take this part to the left hand side, a minus 1 x squared plus b, a minus 1 half, because it is 1 half here, take it to the left hand side, a minus 1 half x squared plus b minus half, plus, plus bx, let me write bx here, plus bx plus c minus half, less than or equal 0. So, because it is always greater than equal 0, so we can say that one necessary condition is the discriminant is less than or equal 0, and always because it is always positive. So, if a is not 0, if a is not 0, then you can, because it says curve, so you can consider a is not 0. But if we didn't have this curve, we should also consider that case. But when we reach last answer, we can see that a is 0 or not. Now, also a must be positive here because it must be opens up. And this is like this or like this. And this part, a minus 1 half should be, it is always less than or equal 0. So if it is quadratic function, we should check at the end of the problem. It must be less than 0 because it is always less than or equal 0. Now we should consider their discriminant. The discriminant here is b minus 1 squared minus 4ac less than or equal 0. The discriminant here is b squared minus 4 times a minus 1 half times c minus 1 half less than or equal 0. So if we consider these two inequalities, let me scroll down. So b minus 1 half, let's see. At first, let's focus on this part. It's equivalent that b squared minus, consider 2 times this and 2 times 4 is 2 times 2, 2 for this, 2 for this, 2a minus 1, 2c minus 1 less than or equal 0. Now if we expand, it will be b squared minus 4ac minus plus 2a plus 2c minus 1 less than or equal 0, which is this. And if we consider this part, it is equivalent to b squared minus 2b plus 1 minus 4ac is less than or equal 0. Now, by star, we know b equals a plus c. So if we use star and these two things, let me call this one the first and second. So if we use star and first, you will reach this a plus c squared minus 4ac plus 2a plus 2c minus 1 less than or equal 0. If you use star and 2, this one, and replace ab with a plus c squared minus 2a plus c plus 1 minus 4ac less than or equal to 0. Now, if we consider this part, it will be a squared plus c squared plus 2ac plus 2ac minus 4ac is minus 2ac plus 2a plus 2c minus 1 less than or equal to 0. Here, a squared plus c squared plus 2ac, we have 2ac minus 4ac, it will be minus 2ac minus 2a minus 2c plus 1 less than or equal to 0. If we add these two inequalities, then we have 2a squared plus 2c squared minus 4ac, they will be cancelled. 2a negative 2a, 2c negative 2c negative 1 plus 1. If we add up these two inequalities, it will be, then we've got 2a squared plus 2c squared minus 4ac less than or equal to 0. If we divide by 2, and then it will be a squared plus c squared minus 2ac less than or 0. And in this way. So here we say a minus c squared is less than or equal to 0. So a minus c squared equals 0 because it cannot be negative. So when a minus c squared is 0, so a equals c. Now, if we replace a equals c in this, for example, 3, then a squared plus a squared, again a equals c, minus 2a squared, this part will be cancelled. Plus 2a minus 1. So 2a plus 2a minus 1 is less than or equal to 0, or 2a plus 2c less than or equal to 1. And also if you use now here, let's call this one 4. If you use 4, they will be cancelled. So 2a plus 2c like greater than or equal to 1. So you conclude that 2a plus 2c, because it is less than or equal to 1, greater than or equal to 1, it equals 1. We know a equals c, so 4a equals 1, so a equals 1 over 4. So until here, a equals 1 over. The problem wants what? 2020. Let's go back. 2020. A squared plus b squared minus c squared. We know b equals 2a because of star. We know b equals a plus c. Here we proved this part. B equals because of this point. So b is 2a. So you can say 2020 a squared plus 2a squared minus a squared. So they will be cancelled. It will be 2020 times 2 squared 4 times a squared. A is 1 over 4. So 1 over 4, 1 over 4. Here, like things I've written here. 4 is 505. So the answer is 505. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 6. Determine the maximum value of x plus y where x and y are numbers satisfying x plus root 1 plus x squared times y plus square root of 1 plus y squared equals 1. It has two solutions. One solution is with Lagrange multiplier, other solutions without that. So let's at first consider Lagrange multiplier. You say, okay, this Lagrange multiplier is useful in many problems of SMO. If you had any question about Lagrange multiplier or any other thing, as I said, feel free to send a message to my WhatsApp number here. Also subscribe my YouTube channel to have next videos and solutions. So G is this. And we say, okay, and f is what? F is x plus y, the thing that we want to maximize. G is the thing that equals 0. You take all things to one side. L equals f minus lambda g, which equals x plus y minus lambda x plus 1 plus x squared times y plus y minus y squared and minus lambda g plus lambda. So if we consider if we differentiate from L in terms of x, it will be y minus lambda times differentiate only from this. If you differentiate, it will be 0. Lambda 1 plus 2x over 2 times 1 plus x squared. And you write exactly this. 1 plus y squared equals 0. Now you say, okay, it is for x, if you differentiate from y, it will be 1 minus lambda. Similarly, you change x and y. 1 minus plus y squared, x plus 1 plus x squared. Both of them are equal 0. Now, if you consider these two things, you will conclude that they are equal to 0. So you can say 1 equals to 1, negative lambda equals lambda. So this part equals this part. So we can conclude that 1 plus 2x. Let's do something. Let's factor from, let's divide these twos. So we conclude 1 plus x squared root plus x, y plus 1 plus root y squared, and you divide it by, if you use common denominator, it will be this. Also, if you use common denominator here, 1 y squared root 1 plus y squared plus y, x plus 1 plus x squared. Now, we want to cancel these things from both sides to reach 1 square root of 1 plus x squared equals 1 plus y squared, but you should check the case that square root of 1 plus x squared plus x equals 0. So if this happens, we conclude that it is equal to negative x, so 1 plus x squared equals x squared. Then 1 equals 0, and that's a contradiction. And so you can cancel all these things, this with this with this. So we conclude 1 plus square root of 1 plus x squared equals square root of 1 plus y squared. So x squared equals y squared. So x equals positive negative y. Now we check both of them and see which of them is better for maximizing x and y, x plus y. Okay, if we replace at first x equals y, then you say, okay, x plus 1 plus x squared equals 1. So x plus 1 plus x squared equals one of them is 1, or x plus 1 plus x squared equals negative 1. So if we check the first one, and 1 plus x squared equals 1 minus x, and raise both sides to the power of 2, 1x squared, we have 0 here. We have what? We have negative 2x. So x equals 0. In this case also y equals 0. So if x equals 0, y equals 0, then x plus y in this case equals 0. In this case, again, if you consider root 1 plus x squared equals negative 1 minus x, again, if we raise both sides to the power of 2, then we have 0 equals 2x. So again, x equals 0, y equals 0, x plus y equals 0. So in these two cases, we've considered the case that x equals y. Now suppose x equals negative y. So we can say, okay, x plus 1 plus x squared negative x plus 1 plus x squared equals 1. Now, if we multiply these two sides, it will be this squared minus x squared. We check it and we need to see 1 equals 1. So in this case, that x equals negative 1, so x plus y equals negative y plus y equals 0. So in all cases, we've reached that x plus y equals 0. So if we want to maximize, we will see that x plus y equals 0. Now we want to use with another solution. Solution number 2, this problem without Lagrange multiplier. I want to consider this function. Suppose that in this solution number 2, my f of x is x plus square root of 1 plus x squared. So if I differentiate from f, it will be 1 plus 2x over 2 times this, which will be 1 plus x squared. So if x is greater than 0 or greater than equal 0, easily we can say that it is positive. Suppose if, so it is ascending if x is less than 0. So consider z equals negative x. So f prime of x equals, then z is positive. Cos 1 minus z, 1 plus square root of z squared. We want to see that is it positive or not. I want to prove that it is positive. So I say it is equivalent to prove that this 1 plus z squared, because both sides are positive. So you raise both sides. You cross multiply because all of them are positive, you can. And then raise both sides to the power of 2. So it is equivalent that it is greater than this. So it is equivalent that 1 is greater than 0. And it's correct. So it is correct. It is correct. It is correct. So it is always, these functions are strictly ascending. Now we say, okay, if x is positive, so let's consider, we should consider two cases. If let's say, if for example x is positive, then it is greater than 1. So if consider this is f of x, so if one of them is positive, then it is greater than 1. So the other one, if again positive, so if x positive, y positive, contradiction, because all of them x plus 1 over x plus is greater than 1, contradiction. If x greater than 0, one of them is at least 0, then one of them is strictly greater than 1, the other at least 1, again contradiction. So the cases that we have, one of them x0, y0, the other one, at first, let's consider if x is 0, if one of them is, at least without loss of generality, if x is 0, it is 1. So you conclude y 1 plus y squared equals 1. Because this function is strictly ascending, And for y0, it is okay, so you conclude exactly y is 0. Because for y greater than 0, it is positive, greater than 1, because it is strictly ascending. We proved it here. F prime is always positive, so we can say if for y0 it has answer, for greater than 0 it is more than 1, for less than 0 it is less than 1. So x is 0, y0, then x plus y in this case is 0. If, for example, one of them is positive, greater than 1, the other one, y, is less than 0. Now, if y equals negative x, so you say, okay, it's x plus 1 plus x squared, negative x plus 1 plus x squared. It will be 1 plus x squared minus x squared will be 1, and it's okay. So, if x is positive, if we fix x, then for y negative x, it is correct. If y is greater than negative x, it will be greater than 1 by the assumption of the problem. It is ascending, and both of them are always positive. If y is less than negative x, it will be less than negative 1. So if x is positive, y is negative, and y is negative x. So in this case, also x plus y equals 0. It was the second solution. Singapore Mathematical Olympiad, SMO 2019, first round open section. Problem number 7. Find the maximum integer m with m equals y plus x such that x and y are real numbers satisfying x squared plus 4y squared plus x plus y equals 0. Again, for this problem, like previous problem, we solve it with Lagrange multipliers. And if you have any question about that, for example, strategy, as I said, feel free to send message to my WhatsApp number here. Also, if you had any other question about the other solutions. So you consider f equals x plus y, or let's write in the order of the problem, y plus x. You want to maximize this, and g is what is the constraint, x squared plus 4y squared plus x plus y. Take all to one side equals 0. Now you consider L equals f minus lambda g, and you say, okay, it equals y plus x minus lambda x squared minus 4 lambda y squared minus lambda x minus lambda y. Now, if you differentiate from L in terms of x, then you will have 1 minus 2 lambda x minus lambda. If you differentiate from L in terms of y, it will be 1 minus 4 times 2. 8 lambda y minus lambda. Both of them equal 0. So we can conclude from first one that lambda equals 1 over 2x plus 1. From second one, you conclude lambda equals 1 over 8y plus 1. Now we should consider at first maybe here the denominator is 0, denominator here is 0, and then we consider they are equal. So case 1. If 2x plus 1 equals 0, it means x equals negative 1 over 2. Now if we replace in g, let's see what we have. G equals 1 over 4 plus 4y squared negative 1 over 2 plus y equals 0. And then we say, okay, g equals 4y squared plus y negative 1 over 4 equals 0. And then we say, okay, g equals 16 y squared plus 4y, yes, minus 1 equals 0. And then y equals what in this case? Y equals negative 4 plus minus 16 minus 4ac, which will be 64 over 2a. But the problem says what? The problem says x plus y has to be integer, the maximum integer m. So if x is this, it will be what? It will be negative 4 plus minus square root of 80. Square 80 is 16 times 5. It will be this over 32. So if you add x and y, x is negative 1 over 2 and y is this plus or minus. You can't get rid of root 5. So x plus y is not integer. So that's a contradiction. Case 2. In case 2, suppose that this denominator is 0. So 8y plus 1 equals 0. So we can conclude y equals negative 1 over 8. And for g, let me copy g from this part. Control C. And now, if we replace y with negative 1 over 8, we can conclude x squared plus 4 times 1 over 64 plus x minus 1 over 8 equals 0. So if we simplify, it will be 16. If we multiply both sides by 16, we have 16x squared plus 1 plus x, 16x minus 2. It equals 0, so 16x squared plus 16x minus 1 equals 0. Now we can conclude what? We can say, okay, x equals negative 16 plus minus 16 squared minus 4ac, which will be plus 64 over 2a32. So it will be negative 16 plus minus 256 plus 64 over 32. If you add up these two numbers, it will be negative 16 plus minus 4 and is 260 and then 320 over 32. And if you take 32 times 2, 64. 64, if you take it 8 root 5 over 32. Now, if y is negative 1 over 8 and x is this, if you add x plus y, which is m, x plus y should be integer, but here you can't get rid of root 5, so it is not integer, so that's contradiction. Now that the denominators are not 0, you can conclude these two terms are equal. So in case 3, you say, okay, 1 over 2x plus 1 equals 1 over 8y plus 1, so 2x plus 1 equals 8y plus 1, and you can cancel y, and then you say, okay, x equals 4y. Now we replace x with 4y in our constraint g. Let's copy this one, Control C. Let's paste it here. Okay. So x is 4y, so the first one is 16y squared plus 4y squared plus 4y plus y equals 0. Now, you say 20y squared plus 5y equals 0. So if you divide both sides by 5, it will be 4y squared plus y equals 0. So you can factor from y, it will be 4y plus 1 equals 0. And then you say, okay, one answer is that y equals 0, case 3, 1. So at first we should consider this. If x equals 0, y equals 0, then x equals 4y equals 0. And in this case, m equals x plus y equals 0. So we found one answer. Now we should also check case 3 too, because we should find maximum number. If y equals negative 1 over 4 means 4y plus 1 equals 0, then x equals what? 4y. So x equals negative 1, so the constraint will be 0. And if we consider x plus y here, it will be negative 1, negative 1 over 4, negative 5 over 4, which is not, because m is this, which is not integer, so contradiction. So the only case that we have is when x equals y equals 0, and the answer for m, maximum m, equals 0. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 8. Among all the real numbers a, b, and c satisfying the equation a plus b plus c equals 0 and abc is equal to 10, find the largest possible value of a cubed plus b cubed plus c cubed. Here again, I think it's the third time in this SMO 2019 we want to use Lagrange multiplier, so that's so much useful in SMO problems. If you want to learn the important ideas and useful ideas for SMO and also other Olympiads, as I said, feel free to send message to my WhatsApp number here. Now, but here in Lagrange multiplier we should have one condition, one constraint. Here we have two, so we should apply one of them. From first one, you say, okay, c equals negative a negative b. And if we replace with this one, it will be ab negative a negative b equals 10. So you can say, okay, g equals what? Negative a squared. Or you can take all of them to the right hand side. It will be 10 plus a squared b plus ab squared equals 0. And f is what? F is a cubed plus b cubed. You substitute c with negative a minus b. It will be a cubed plus b cubed minus a cubed minus b cubed plus, let's say it will be negative 3a squared b, negative 3ab squared. So you can cancel these things. So you have this for f. Now L is what? L is f minus lambda g. So it will be negative 3a squared b minus 3ab squared minus 10 lambda minus lambda a squared b minus lambda ab squared. Now, if we use here, if we differentiate from L in terms of a, then we have what? Negative 6ab minus 3b squared minus 2 lambda ab minus lambda b squared. It equals 0. Now let's differentiate from b. We have negative. Let's simplify the first one at first. So here we conclude what? We conclude lambda times negative lambda times 1b squared plus 2ab over, and take it to the right hand side, 6ab plus what? Plus 3b squared. So you conclude negative lambda equals 6ab plus 3ab squared over what? Over b squared plus 2ab. Now, if you differentiate from L in terms of b, okay, but here I should only correct this one. It is 3b squared. I've written one extra a. So it is this. Now, let's differentiate from L again. It will be what? Negative 3a squared minus 6ab minus lambda a squared minus 2 lambda ab equals 0. Now we can say what? We can say negative lambda a squared plus 2ab equals 3a squared plus 6ab. So again, we can say negative lambda equals 6ab plus 3a squared all over a squared plus 2ab. So we should consider that the denominator is equal to 0. Then case 1, this is 0. Case 2, this is 0. Also, if this denominator is 0, means the left hand side is 0. So also right hand side 0. And then in the third case, last case, we should consider these two things are equal. So in case 1, I write b squared plus 2ab equals 0. Because abc is 10 here from the assumption of the problem, abc is 10. So a, b, c are not 0. So b is not 0, you can divide by b plus 2a equals 0. So b equals negative 2a. And also, you know that if this one equals 0, then this one also equals 0. So 6ab plus 3b squared equals 0. So you can divide by 3b. So if you divide by 3b, again 2a and 3bb, you will reach same thing. So b equals negative 2a. We know what? We know a plus b plus c equals 0. So negative a minus 2a plus c equals 0. It is negative a, so c equals a. Now we've reached what? A. Negative 2a for b, and for c, a. Now if we use the here ABC is 10, then we want to find a cubed plus b cubed plus c cubed. ABC is 10, so you can say, okay, Negative 2a cubed equals 10. So a cubed equals negative 5. So a equals negative third root of or cube root of 5. And now in this case, a cubed plus b cubed plus c cubed equals what? Equals a cubed. B is what? Negative 2a. So it will be negative 8a cubed plus ca cubed. And it will be what? Negative 6a cubed. It will be negative 6. This cubed will be negative 5. And it will be 30 in this case. Okay, case 2 is what? Case 2 is that if this denominator equals 0, a squared plus 2ab equals 0. Case 2, a squared plus 2ab equals 0. Again, we say, okay, a is not 0, a plus 2b is 0, so a is negative 2b. And if you consider we have symmetry between a, b, and c, so you can say similarly you will reach in this case 30. Now, the last case we should consider is that the denominators are not 0. And then we can say what? Let me copy paste them here. Okay, case 3. The denominators are not 0, so they are equal. Now you can cancel here from factor from 3b. It will be a plus b squared. 3b a plus b. And then you factor from b here, it will be b plus 2a. So let's check it again. 3b 2a. Here you're right. 2a plus b and 3b squared. So you can cancel because we know denominator is not 0. You can cancel. It is 3. Also, you consider, so negative lambda is 3. If you can consider again this part also, you will see what? You will see 6ab equals what? You factor from 3a to b plus a. And also you factor from a here, it will be a plus 2b. You cancel. Both of them are equal 3. So you find that for any other, for lambda equals negative lambda equals 3. So you can see that they will be satisfied. And in this case, you can select any ABC. You can select one of them and see that here the answer is the maximum answer for a cubed plus b cubed plus c cubed equals 30 here. If you had any question about the answer, wanted more explanation, as I said, feel free to send message to my WhatsApp number here. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 9. Suppose that the solution set of the inequality absolute value of x minus 1 plus absolute value of x minus 6 is less than or equal 9 is given by x between a and b. X is greater than equal a less than or equal b for some real numbers a and b. Find the value of b minus a. If you draw y, let me write y equals absolute value of x minus 1 plus x minus 6, then y is this function. Why? Because the important points are 1 and 6. You say if x is greater than equal 6, then y is what? Y is 2x minus 7. It is this part. If x is between 1 and greater than equal 1 less than 6, y equals what? X minus 1 plus 6 minus x, which equals 5. It is this part. And the last part x less than 1, it will be y equals 1 minus x plus 6 minus x, which equals 7 minus 2x. It is exactly this part. And when x equals 0, y-intercept is 7. Now, the problem says what? This function y is less than or equal 9. 9 is this red line, dotted line is given by x greater than equal a. So let me check this point. X for this point is a, for this point is b. Now if I want to find a, I say okay, this function is what? X less than 1. 7 minus 2x equals what? Equals 9. So you can conclude 7 minus 9 equals 2x, so negative 2 equals 2x, so x equals -1. So A in this case equals -1. For B, let me write in this case with B, 2b minus 7 equals 9. So 2b equals 9 plus 7, 16. So b equals what? 8. Now b minus a equals what? 8 minus minus 1 equals 9. So the answer is equal to 9. SMO 2019 Singapore Mathematical Olympiad first round open section problem number 10. Let a and b an infinite sequence with a1 equals 2 and an plus 1 equals an plus 4n plus 2. For all n greater than equal 1, determine limit when n approaches infinity. 22,000 times 1 over a2 minus 2 plus 1 over a3 minus 2 plus dot 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 plus 2 1 over an minus 2. Okay, so when you see something like this, there are around, I can say, three useful ideas. Also, there are some other ideas to find a recursive sequence. This is so much easy because the coefficient are 1, sometimes the coefficient are constant, for example 4, 5, or sometimes in terms of n, and also we have some other recursive sequence. If you want to learn how to find them, as I said, feel free to send message to my WhatsApp number here. So for this part, you say an plus 1 minus an equals 4n plus 2. Then you say, okay, an minus an minus 1 equals what? Equals 4 times n minus 1 plus 2. And then you write until a2 minus a1 equals 4 times this, 4 times 1 plus 2. And if you add up all these numbers, we know a1 is what? A1 is 2. So an plus 1, I've cancelled, means this one with this one. An minus 1 minus a1 equals 4 times 1, 2 to n, plus how many 2's do we have? 2n. n 2's we have. So a1 is what? A1 is 2. We can say an plus 1 equals 4 times n plus 1 over 2 plus 2n plus 2. So if we write an plus 1, if we simplify, it will be 2n times n plus 1 plus 2 times n plus 1. So we can factor from n plus 1. It will be, if I factor from 2n plus 1, it will be what? It will be n again plus 1. So it will be 2n plus 1 squared. So we can say that an equals 2n squared. If we decrease the index by 1, we will reach this. Now let's replace a with the things that we want. As n approaches infinity, 2000, 1 8 over a2 minus 2 plus 1 over a3 minus 2. Let's check. Plus 2, 1 over an minus 2. Now, I consider at first this one an. So an is what? Is 2000. If we replace this, it will be 2 times 2 squared minus 2 plus 1 over 2 times 3 squared minus 2 plus 1 over 2 times n squared minus 2. We factor from 1 over 2, it will be 1000 over 2 squared minus 1 plus 1 over 3 squared minus 1 plus 1 over n squared minus 1. 1 over I squared minus 1, you can say it is I minus 1 minus 1 over I plus 1. But if you consider this, it will be I squared minus 1, I plus 1 minus. So you should factor from 1 over 2. So here I say, okay, 1000 over 2, which will be 500. 1 minus 1 over 3. Like 2 minus 1, 2 plus 1. 1 over 2 minus 1 over 4. And we write 1 over n minus 1 over n plus 1. So if I simplify this, it will be what? 500 times. If I write on top of each other, 1 over 2 minus 1 over 4, 1 over 3 minus 1 over 5, and write 1 over 4 minus 1 over 6, and the last one is 1 over n minus 1, 1 over n plus 1, 1 over n minus 2 minus 1 over n. If I write like this, then I will cancel this one with this one with this, and also then I have these two terms all left. It will be 500, 1 over 1 plus 1 over 2 minus 1 over n minus 1 over n plus 1. And it equals what? It equals 500, 3 over 2, and minus 1 over n minus 1 over n plus 1. And now if we consider the limit when n approaches to positive infinity, an, we've defined an what? We've defined an is this. An is this, so it will be equal to, it will be 0, it will be 0, it will be 250 times 3, which equals 750. So the answer equals 750. Singapore Mathematical Olympiad SMO 2019, first round open section problem number 11. Let a greater than b greater than 0. Let a be the minimum value of 2019, a plus 1 over 2019 times a minus b times b. Determine floor of a. For solving this problem, we consider a as a plus, let me tell you, it's better to write, because b, a minus b, we want to use AMGM, arithmetic mean, geometric mean, inequality. So I can say b plus a minus b, the first one, it is 1a. So it is first one again plus b plus a minus b, second one plus 2b plus a minus b, 2019 1, and 2019 1. So the next one is you consider 1 over, because we should consider 2019 for each of them, because look, it is first one, but I consider each of them one case. Let me tell you, it's, for example, x1 for me, it's x2, it's x3, it's x4. We want to use AMGM for xi's, so it will be x, let me tell you, x40 38, x40 37, and the next one, you should have 2019 of this term. So you write 2019 squared a minus b times b plus 1 over 2019 squared a minus b times b. So I consider it is a. So a is the minimum. So let's consider this part f. So this part is f. Now, if I use AMGM for this part, let me divide it by what? If I draw fraction, if I use AMGM, let me draw with blue. Then I have what? I have here 1, 2, 2 times 2019, 2019 here we have 2019 terms. So over 3 times 2019. It's greater than equal square 3 times 2019 root of product of them. B, they will be cancelled. A minus B, they will be cancelled. It will be what? It will be 1 over 2019 squared to the power of 2019. And you can cancel these two. So you will have cube root of 1 over 2019 squared. Now we can conclude f is at least 3 times 2019 times cube root of 1 over 2019 squared. Now here we can say, okay, f is greater than equal 3 times cube root of 2019 cubed. If you take 2019 inside, it will be 2019 cubed over 2019 squared, which equals 3 times cube root of 2019. Now, the equality happens, we know, for AMGM when b equals a minus b equals this. Also, if you want to know, when equality happens, in this case, equals 1 over 2019 squared a minus b times b. So in this case, you conclude that 2b equals a. So 1 over 2019 squared a equals 2b. So it will be b times b squared. It equals what? B. So b is what? B equals 1 over 2019 cube root of 1 over 2019 squared, and a equals 2b, so a is greater than b, greater than 0. In this case, equality happens. Now, so the minimum is this, equality holds for this b and a, so the problem says what? Find floor of a. So a is this. If we want to find floor of a, so you can say, okay, floor of a equals floor of, you can say cube root of, take 27 inside 2019. So if you multiply these two numbers, 27 times 2019, 63, 13, 1, 14. 2 times 9, 18, 1, 3, 0, 4. So it will be this 11, 4, 5, and 4 and 5, 54, 51, 3. Now, if we want to check, for example, if we check 20 cubed, it will be 8,000. If we check 30 cubed, it will be 27,000. If we check 40 cubed, it will be 64,000. So you understand that A is between 30 and 40. Now it's somehow like binary search. Then we check half of them. Midpoint, it's 35. If we consider 35 cubed, it will be 35, 17. It will be this 12, 2, 1. 1, 2, 2, 5 times 35. It will be 1, 5, 5, 25. We have 2, 5 times 2, 10. We have 2, 12, 1. 5 times 2 plus 1, 11, 1. 5 times 1 plus 1, 6. 3 times 5, 15. We have 1. 3 times 2, 6, 7. 3 times 2, 6. 3 times 1, 3. So it will be 5, 7, 8, 12, 42. 87, 5. So we understand, okay, because it's still less than that. So A is at least 30. Because you should consider floor of that. You understand that, okay, A is greater than 35, less than 40. So you can check this for 38. For example, 38. If you multiply 38 and if you calculate that, 6, this, and 3, 3, 11. So 4, 4, 4, 1. Okay, so if you multiply it again by 34, 38, 32, 3, 5, 3, 5, 3, 11. And then we multiply 3, 12, 1, 13, 1, 13, 1, 3, and 4. Okay, it will be 2, 7, 8, 4, 5. Now we understand, okay, A is less, it is near this number, A is less than 38. Because this number is less than this, so A is less than 38. And you can easily prove that A is greater than 37. So if you want to find floor of A, it equals 37. So the last answer equals 37. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 12. Let x1 plus x2 plus 2 plus x99 equals net 9702 and x1 squared plus x2 squared plus 2 plus x99 squared equals 96049 8. Determine the largest possible value of x. So for solving this problem, let me tell you, for example, we should do what? Suppose at first I will explain the solution with some example and then we will solve for general x1. If, for example, x1 equals 0, then if x1 equals 0, x2 plus x99 equals 9702 and x2 squared plus 2 x99 squared equals 960,498. Now we know by QMAM, we know it is true for, at first you say for positive integers. Let me write, because we know, for example, QM, AM, GM, HM are true for positive x1, x2. Let me explain it first here. Let's only use for x2 to x99. x99 squared over 99 is greater than equal x2 plus 2x99 over, sorry, because the numbers are 98 from x2 to x99. 98, so we raise both sides to the power of 2. 90 squared greater than equal x2 plus x99 over 98. We know 98 squared and divide by 98, it will be 98. We know it's correct for positive integers, positive real numbers. Also, if you change, for example, if one of them is negative, left hand side won't change, but right hand side will decrease. So we say it is correct for all real numbers. Now, if you pay attention here, we consider it is Q. We call this part Q. In general, that's because it is the special case. We call this one Q. We call the sum of them, for example, S. So we know what? We know Q is greater than equal. We proved S over, for example, here we have 98 numbers, S over 98. And we want to say Q is at most what? Q is at most, for example, look here, if we want to find, for example, suppose that S is fixed, sum is fixed. For this sum S, we want to see that x2 squared to x99 squared is at most what? You can consider two numbers, for example, minimum and maximum number, without loss of generality. Suppose that they are like this. So you can say, okay, I change x2 to x2 plus, for example, alpha, a large number, x99 minus alpha, a large number. Sum won't change because plus alpha minus alpha. What? The square will change if alpha is a large number. So you can say it can go to infinity, less than infinity. So from here, we don't have any problem. We should only pay attention to this part. So here we say, okay, we want to solve it for general x1. We say what? We say S is what? S is, the number is what? 906498. 6498 minus x1. Q, sorry, it is not S, it is Q. Q is this minus x1 squared. S is what? 9702 minus x1. If we use this inequality, then let's see what we have. 960,498 minus x1 squared greater than equal 97. And let me tell you something. Here, when we raise both sides to the power of 2, it will be this squared, s squared. And s squared here also now over 98. So s squared, now we say, okay, s is this. So it will be 9702 minus x1 squared over 98. Now we want to find x1 that's maximum x1, because the problem says find the largest possible x1 that satisfies this inequality. Now we want to see between these numbers, do we have any relationship? So if we want to write, at first let's multiply. It will be 98 times 960,498 minus 98x1 squared greater than 9702 squared minus 2 times 9702x1 plus x1 squared. So if you take 98x1 squared to the right hand side, we will have 99x1 squared minus 2 times 9702. If you check, it is multiple of 9, and if you want to check multiple of 11, the rule is this. Plus from right, plus minus. You will see it is also multiple of 11. So we can say 90, let's divide it by 97, 99. So if you divide it, we have 99. Okay, it will be this. And here we have 692. So it will be, let's check if we multiply it by 6. If we multiply it by 7. Sorry, here 9981 we have 8. 9981 we have 8. 81 plus 8 is 89. So let me correct it. 89. So 1 minus 10 minus 9 is 9. It will be what? It will be 6. 16 minus 9 is 7 and is 0. So this one, if we place 8, 8 times 9, 72, 7. 8 times 9, 72. Times plus 7 is 79. 0. So this number is what is 98 times 99 x1. And this one here, we want to calculate. Let me write the rest of that with black. We have 98 here, and we found it is 9702 is 99. So let me write 98 times 960498 minus this one, 98 squared, because we factor from 98, it will be this, times 99 squared. So let's check, is it multiple of 9 or not? 8, 4, 12, 6, yes, it is multiple of 11. And if we want to check, is it multiple of 11 or not? Plus, minus, plus, minus, plus, minus. Negative 1, 3, 3 plus 6, 9, 9 minus, yes, so it is multiple of 99. If we factor from 99 here, let's check. 498, factor from 99. Here we will have 9, it's 891. 1, 10 minus 1, 9. It will be 5. 15 minus 9, 6. 6, 9, 4. If we consider 7, 63 is 6. 69. Okay. We have 1 here. Then we have 9. We place 0 here. 198. Then we have 2 here. Okay, that's a good number. Because here we say, okay, it is 98 times what? 99 times 9702. Here we know 98 times 99 is 9702 times 99. So you will understand that it is equal to this part equals 0. Now, we conclude what? We conclude 99 x1 and x1 minus 2 times 98 is less than or equal 0. So if we consider the roots, here x1 0, here x1 1 9 6. So because it is less than 0, if you consider, it will be this 0 1 9 6, because it is strictly less than or equal 0. So the maximum number that x1 can get, maximum x1 is in this place, equals 196. So the answer equals 1. Singapore Mathematical Olympiad, SMO 2019, first round, open section, problem number 13. Find the largest positive integer n satisfying the following condition. There exists n positive integers a1, a2 to an such that absolute value of ai minus aj is a product of two distinct prime integers for all I that is not equal to j. So when we see this problem, you should find, for example, let me tell you also in round 2 problems, you should say, okay, the answer is greater than equal, less than or equal. How? One part, most of the time, usually with example, one part with proof. For example, if you find example with 3 elements, you see that the answer is greater than equal that number, because you should find the largest positive. And here with proof. So look, 4 is not prime number. You should work on both of them. If n is greater than equal 5, then there exists I and j, that I is not j, and the remainder are equal, means 4 divides ai minus aj. So if you consider the difference, this is multiple of 4, and that's a contradiction because it must be product of two distinct prime integers, but it is 4 times something and it's contradiction. So we proved that the answer is at most 4. Now we want to try to find some example. For example, what? The numbers that are product of two distinct prime numbers are, for example, 6. Next one, for example, 10, 3 times 15. So if you consider, for example, 1, 7, it is 6. Now if you consider 1 plus 15, 16, 16 minus 7 is 9. So if you consider 10, let's consider another number. 2 times 7 is 14. And so look, if you consider the difference 6, we have 6, 15, 10, 14, 3 times 7, 21. So we have, for example, the difference 6, the difference 15. So the result is 27. So we found an answer with 1, 7, 22. So it is 3. So the answer is 3 or 4. It's this. I want to. I don't want to only solve this problem, tell you solution is what, how. I want to show you the strategy, the algorithm you should do to solve problems like this. So maybe you should find, because we don't know, suppose we don't know the answer is what, we are the exam. So maybe the answer is 3 or 4. So for example, if it was round 2 problem, if you write example for this, proof for this, so you will get at least some part of the marks score. Here we try to find example greater than 3. If we couldn't, we should try to see, okay, maybe the answer we can prove is at most 3. So here, if we consider, I've tried some examples and then I've written the numbers that are product of two prime numbers. For example, I said, okay, 6 is okay, 7, 8, 9, 10. 10 is okay, 11, 12, 13, 14 is okay, 15 is okay, 16, 17, 18. 18 is not okay, 19, 20, 21, 22, 23, 24, 25, 26 is okay, 27, 28, 29, 30, 31, 32, 33 is okay. 34 is okay. 32 times 17. 35 is okay. 36, 37, 38 is okay. 39, 40, 39 is okay. 40, 41, 42, 43, 44, 45. 46 is okay. And 46, 47, 48, 49, 50, 51 is 3 times 17, 52, 53, 54, 55, 56, 57. 57 is 3 times 19, 58. 2 times 29, 60, 61, 62. 2 times 31, 63, 64. 63 is not, it's 9 multiple of 9, 64, 65. I've checked many of these numbers and I saw that, okay, if I select 65 here, also I think it has another answer. And probably it has more than one answer. So if you consider 65, and then we will reach what? 87. So their difference is what? Let's check. Let me copy these numbers and check. Do they satisfy the condition of the problem? So here, let me consider the rest of that with black. So all these three are okay. 65 is okay. If you consider the difference, 80. So here, 80 is not okay. So at first, I've checked this and I saw, okay, it is not answer So then I tried to start from first. I said, okay, let's consider the first one is 1. And then I said, okay, for example, let's consider the numbers here we've written. Then I said, okay, I considered 1, 6, 7, 10. I also checked. Then I said, okay, 1, 15. So the difference is 14. And then I've considered 36. Their difference is 21. And then I've considered 70. So the difference is what? 34 here. And let's check 136 is 35. That's okay. 15, 70 will be 55. That's okay. So we should consider 4 choose 2 pairs. 1, 2, 3, 4, 5. And the last one that we should check is, let's see, 1, 2, 3, 1, 2, 3 with all of them. This one, it is 69. It is what? 3 times 23. So also look, 65, 67, 68, 69. So we found an example with 4. So the answer is 4. That's how we can reach the problems like largest positive, smallest positive. If you want to learn how to solve harder problems for round 2, as I said, feel free to send message to my WhatsApp number here in description. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 14. Let a, b, and c be integers satisfying ab plus bc plus ca equals 1 and 1 plus a squared times 1 plus b squared times 1 plus c squared equals 69, 23, 90, 41, 00. Determine the value of absolute value of a plus b times b plus c times c plus a. Okay, for solving this problem, I can say you can consider many ways to finding, for example, a, b, c, but here we don't want a exactly, a, b, c. We want this term. So we can say a, b. If I write like this, I can say a plus b, for example, a plus c. Then I have what? A squared, ab, ac, bc. So it equals what? It equals ab, bc, ca is 1, and we have 1 a squared plus 1. So it is this. Now, also, if we consider for b plus a, b plus c, we can say it is equal to b squared plus 1. C plus a, c plus b, it equals c squared plus 1. So if we multiply, let me consider this one, for example, a. If we multiply both sides, a squared equals 1 plus a squared, 1 plus b squared, 1 plus c squared. So big A squared equals 692,390,4100. So here, if you want to find a square root of that, there is an algorithm and it's so much useful. I will show you how to find square root of this easily. If you had any question about the other things, feel free to send message to my WhatsApp number here and also in the description. Now, let's find this. Because it is times 100, we can say, okay, square root of that will be 10 times square root of 692. Let me write it a little better. 692,390,41. So, 41. Now I want to find square root of this number. So if I want to find square root of this number, let me copy this one. Okay, you do like this. You say, okay, from right, I consider this, this, this. Then I say, okay, what times what is less than, what squared less than or equal 69, and it's the greatest possible 8. It will be 64, then you have 5, 2, 3. Then you consider twice this, 1, 6. Now, you should place equal numbers here. 1, 6, 3, I think it's okay. 3, 3, 9, 3, 6, 18. We have 1. 3 times 1 plus 1 is 4. If we subtract, 13 minus 9 is 4. It will be 1. 11 minus 8 will be 3. So it's 34. Now you consider and you place these three here. It's 5, 2, 3, 34. Now you place 9, 0. Then you consider twice of 83. It will be 6, 166. Now you should place here. It's around 1600. So you should place 2. 3 will be around 4000. 2, 2, 4, 2, 6, 12, 1, 2, 6, 12, 1, 13. 1, 2 times 1 plus 1, 3. If you subtract 10 minus 4 is 6, 8 minus 2 is 6, and 4 minus 3 is 1. So you place 2 here, and the last part, 41. Now we consider twice this number, 4, 6, 16. And now it's obvious that you should place 1, and it will be this, and you understand, okay, this number was a perfect square, and it will be 8 times 8321, so the answer is 8321, 0. Singapore Mathematical Olympiad SMO 2019, first round open section. Problem number 15. So in the triangle ABC, AB, which is C equals 209, A equals 171, and B equals 190. M is the point of BC. M is the midpoint of BC. Okay, so it is median. You can call AM MA. Point L is on the extension of BA here. This L. And point N is on the extension of MA, such that CL and are collinear, and AL equals NL. Find the length of AN. Okay, so we call AN Y and we call this X. So if we, for this problem, we should know at first the formula of median. As I said, there are around 50 important formulas in geometry you need from qualifying level round 1 up to IM. If you wanted to know them, as I said, feel free to send message to my WhatsApp number here. Now, MA squared is B squared over 2 plus C squared over 2 minus A squared over 4. If we calculate that, it will be 190. And this number, let's consider these numbers. It is what? It is 19 times 10. If we prime factorize, 19 times, let's check, it's 8. No, 19 times 9. And this one is what? It's 19 times 11. Yes. So one thing that we can do is, okay, we can factor from 19 squared, because all of them have 19. It will be the first one, B squared. It will be 100 over 2 plus C squared is 121 over 2 minus A squared over 4, which is 100 over 4. If we calculate that, it will be 19 squared. If we, let's divide it by 2, 50. Then let's see what we have. I'm sorry, here minus A squared over 4, which is minus 9 squared over 4. So let's check B squared, C squared. Okay. So here we say it's, so let's connect. Okay, so if we consider a common denominator 4, it will be 200 plus 242 minus 81, which equals 19 squared over 4 times this plus this will be 244 minus 81. And if we calculate that, it will be 2 minus 1, 1. 14 minus 8, 6, and 3. So it will be 19 to the power of 4, because 361 is 19 squared. As I said, memorize at least until 30 squared the perfect squares. So we can conclude MA is what? MA is 19 squared over 2, which equals 361 over 2. Now, We use Menelaus's theorem. It is also useful in Menelaus's theorem. Let's see for what, because we have collinear points. Okay, so let's correct it. Menelaus's theorem. Now we use Menelaus's theorem in triangle ABM and line or ABM and these three collinear points. So if we use that, let me copy this figure, Control C. Okay, so the first one here, we can say NA, which is, let me write that first, NA over NM times CM over CB times LB over LA equals 1. NA is what is Y. NM is what? Y plus MA. CM over CB is 1 over 2 times LB. LB is what? X plus what? X plus C over LA, which is X equals 1. Now I say, okay, Y times X plus C. C equals what? 209. Let me also copy these three sides. Control C. Paste it here. Okay. Y times X plus C, which is 209, equals X times 2Y plus 2MA. MA was what? MA was 361 over 2. So 2MA is 361. Now I can find the relationship between Y and X. I say, okay, YX plus 209Y equals 2XY plus 361X. So XY equals 209Y plus 361X. So if we want to find Y in terms of X in terms of Y. So we can say what? We can say X times Y plus 361 because we want to find Y. So X is what? X is 209Y over Y plus 361. Now we want to use another thing. Consider it is cos A1. So if we maximize the triangle ALN, it will be something like this. And if we draw altitude, it is X, because it is X isosceles triangle, it will be Y over 2. So it is also A1. These two angles are equal. So cos A1 is Y over 2 adjacent side over hypotenuse. So it will be Y over 2x. So also we can use cos rule. So cos A1 equals Y over 2x, or you can also use cos rule in triangle ABM. It will be what? It will be MA squared plus C squared minus A over 2 squared all over 2MA C. Now, let's see how we can simplify this term. Y over X is what? Y over X is Y. Here we can say Y over X is Y plus 361 over 209. So I replace here Y plus 361. Also, at first I multiply both sides by 2, so these two will be cancelled. So Y over 6 is Y plus 361 over 209 equals MA squared is what? 361 over 2 squared plus C squared, which is 209 or 209. You can say, okay, it is 19 times 11. Let me write like this. 19 squared times 11 squared minus A over 2 squared, which will be 19 squared times 9 squared over this A over 4 all over MA times C. MA is what? Is 361 over 2 times A times C. C is what? 19 times 11. Now, if we simplify, 209 is what? 19 times 11. So you can cancel these two things from both sides. Then let's see what we have. Y plus 361 equals 361 squared over 2 over 361 over 2. So you can say the first one is 361 over 2, and then plus 19 squared, it will be cancelled, and it will be 11 squared times these two, and then the next one. 19 squared will be cancelled, minus 9 squared over 2. So here we will have, let's calculate, y plus 361 equals 361 minus 81 over 2 plus 2 times 121. So the first one is 0, 16 minus 8 is 8, and it's 280 over 2 plus 2, 1 times 121. It's 140 plus 242. Now, let's see, it will be what? Y plus 361 equals 283. So y equals this minus this. 2 minus 1, 1, 8 minus 6, 2, 3 minus 3, 3, 0. So the answer, that is y equals 21. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 16. Let a over b be the fraction with the smallest positive denominator such that 386 over 2019 less than strictly less than a over b is strictly less than 35 over 183. Determine the value of a plus b. If we multiply by b, then we have what? We have 386 b 2019 less than a strictly this a less than strictly 335 b over 183. Now if we consider the number lines, it means what? Let me draw. Okay, it means that, for example, a is some integer, a is an integer here, positive also. Denominator, it's with smallest positive denominator. So because denominator is positive, also numerator should be positive because it is between two positive numbers. So it is this, and 35b over 183 must be someplace like this, and this one 6b over 2019 must be some numbers between, a must be between these two numbers, integer. Now we say, okay, let's consider their difference. 35b over 183 minus 386b over 2019. Now if we want to use common denominator, we see that both denominators are multiple of 3. It is 3 times 61, and it is 3 times 673. So if we want to use common denominator, it will be 3 times 61 times 673. And if we factor from b, it will be 35 times 673 minus 386 times 61. So we want to see it equals what? At first, let's multiply 673 by 35. 5 times 3, 15. 36, 3. 5, 33. 3, 3, 9. 21, 2. 18 and 2, 20. It will be 5, 15, and 4, 5, 3, 2. The next one is 386 times 61. It will be this, and 6 times 6, 36, 3. 6 times 8, 48, 51, 5. 6 times 3, 18, plus 5, 23. And it will be 6, 14, 4, 3, 2. And if we subtract this minus this, 15 minus 6 will be 9. And it will be 4. 4 minus 4 will be 0. And yes, 4 minus 4 will be 0. Here, sorry, 6 plus 8, 14. We should correct it here by 5. If we subtract 15 minus 6 will be 9. It will be 4. 4 minus 4, 0. The rest of them will be 0. It will be 9b over 3 times 61 times 673. And if we simplify, it is equal to 3b over 61 times 673. Now here we want to consider something. At first, let me copy this number line, Control C, and paste it here. Okay, so we know that it is greater than integer, this integer. So if I want to consider this part, because the denominator is 183, it is at least greater than equal what? 1 over 183, because it is strictly greater than this integer. So it is greater than this. Now, if I want to consider, I can say 35b over 180. At first, let me tell you something like this. Their difference, we found the difference. It's 3b over 61 times 673. It is strictly greater than, because it is also greater than 0, so it is strictly greater than 1 over 183. And now, if we simplify this, it will be 1 over 3 times 61. If we cancel, then it is equivalent that b is greater than 673 over 9. It will be 7. 43, you can say 4 point something. So you can conclude b is at least 75 in this case, that it is greater than 1 over 183. Now, let's consider the equality, for example, case 1. Suppose that it is exactly equal to this, means 3b over 183 minus 1 over 183 equals exactly a. So what can we conclude from this? Then we can say, okay, 3b minus 1 over 183 equals a, that a is a positive integer. It means what? It means that 3b minus 1 is multiple of 183. So let's analyze this. 3b is 1 mod 183. Now, if I multiply by, let's see, let's check. Sorry, I think on this number was not 3b, 35b. Let me correct it. 30, because it is not, it can't happen. 35b, because it is multiple of 3, multiple of 3. 35b minus 1, so you can place also here 35b is congruent to 1 mod 183. Then we multiply it by 5 and we will see, okay, 175b is congruent to 5 mod 183. And then we can say, okay, 175 is negative 5, negative 8. Negative 8b is congruent to 5 mod 183. Now, if I want to consider 8, it's 20, 23. Let's multiply it by 23. It will be negative 184b is congruent to 5 times this. It is this mod 183. And then we say, okay, it is what? Negative 184. 184 is 1, so it is negative b, so b is negative 150 mod 183. So we can conclude b is what? 183 plus this. 183 plus negative 115. It will be what? 13 minus 5, 8. And now 7 minus 1 equals 6. So we've concluded that it must be this number. So let's consider the cases. If B is 68, let's at first, or for example, B is what? 183 plus this will be 1. 3 plus 8, 11. We have 1, 6 plus 8, 14 plus 1, 5. And plus 1, 15. We have 5 here and 251 or something else. So let's check what can we do for 68. We know what? We know A is between these numbers. See? Okay. Now, for the first part, if I replace B with 68, then I have this times 68 over 2019 less than A less than 35 times 68 over 183. So for this part, you can say what? You can say it is 2 times this 70 times 34, and if we multiply it will be 0. 7 times 4 28, 2 7 times 3 21 and 23. For this part, if we multiply it will be 3 8 6 68 48 4 we have 68 6 we have 30 36 351 5 23. So this 1 we have here 2, so it will be 6 2. Now if we divide at first the right hand side, it will be 380 over 183. So you have what? 183. It will be 5. 13 minus 8 which will be 5 0. So 2 3 3 3 9. 3 times 8 24. We have 2. 3 times 1 2. And 3 times 1 3 plus 2 5. So it will be 13 point something, the right hand side. Now let's consider left hand side. If you divide, it will be 26248 all over 2019. So the first one is 2019. And if you place here 14 minus 9 5, and it will be 1 1 minus 1 0. Then it will be 6 minus 6. It is 8. Now if we consider, if we place 3 times 9 17 and 27, we have 2 5 0 6 1. So it is 13 point something. So it is impossible because here we have 13, here we have 13. So it is impossible. Now let's check for 251. So if we place, let me copy this part for 251. Control C. Now if I multiply the for 251, it will be 35251 over 183. So let's write 35 over times 251. 5 5 25 12 3 15. Okay, 7 5 and then 8 7 8. So it will be 8785 over 183. Now let's multiply 386 times 251. The first one is 386, 33, 43, 4, 19, 12, 17, 7, and it will be 8, 5, 8, and 16, and it's 9. Now we divide again. How we say, okay, let's consider at first this part. It will be what? It will be 8, 7, 8, 5 over what? Over 183. So if you consider the first part, now it will be around 4, because 5 times this will be more than 904. 4 times this, 4 times 3, 12. We have 1, 4 times 8, 32, 33. We have 3, 4 times it will be 7, it will be 6, it will be 4, it will be 1. And this part, if we want to consider, it will be Okay, if we place 8, 24, we have 2, 66, we have 6, and 14. Again, the remainder is 1. So here it's 48 point something. Now let's divide this number by 2019. This by 2019. Now if we consider this part, 4 times around 8,000. Okay, 4 times 9, 36. We have 3, 7, and 408. So if we subtract, it will be 2, 1, 6, 1. And then if we place 6 here, it will be, okay, it will be 3, 6, 13, 1, 14. So let's check, it will be 3. 12 minus 3 will be what? Will be 9. And 0, 10 minus 1, it will be 9. And here, okay, 1993. So it is 47 point something and 48 point something. So 47 point something A and 48 point something. So A equals 48 satisfies this. And now, okay, A equals A over B equals 48 over 251. So in this case, A plus B is what? A plus B is 9 and 9299. Now, we found for B that equals 251. So in this case that we considered, okay, 35B over 183 minus exactly 1 over 183 equals A. Now we should consider the other cases. So at first, let's consider something. We say, okay, their difference if I copy and paste number line. So we know that we found answer for B25. So if we can find better answer, B should be less than 251 or less than or equal to 50. Now, here we say, okay, their difference was what? Their difference was this part, 3B over 61673. 3B over 61673. If this one is, for example, we want to consider, it can be 2 over, for example, 183. It cannot be. If this is exactly 2 over 183, so it is greater, strictly greater than if this is this 61673, it is greater than 6183. Now, if I write for it is, for example, this one is 4 or greater, 673 for 4 183 or greater than that, you can reach contradiction. This part you can see that B 250 doesn't work. How? You know that it is 3 times 250, 61 times 673. So you know that 3 times 250 times 183 is greater than 4 times 61 times 673. And for example, if you divide, it will be 2, it will be 125. And you can reach contradiction. How? You can say, okay, it's greater than, for example, 2 times 61. If we add this by 2, it will be 675. Then you can divide by 3. So it will be 125 times 183. This by 3, 261, 3. And if you divide by 3, it will be 2, 2, 5. And if you divide this by 25, it will be 5. If you divide this by 25, it will be 9. And now we want to reach for this part contradiction. How we say, okay, for this and this one, you say, okay, 9. We have this. And this. So it's a contradiction. Now, we said, okay, we've proved this part, so the only thing that we should check, it is exactly 2 over 183 and 3 over 183. So it means what? It means that 35 over case 2, 35 over 183 We need to only consider two other cases. 32.5 over 183 is equal to 2 over 183. And in the second case, we should check for 3 over that. So here, it's minus a, minus a is this. So we say, okay, 35b minus 2 over 183 equals a. So we can conclude 35b is congruent to 2 mod 183. We found for 1 is what? We multiplied b by what? It was, let me find it here. We proved that b is 68. So if you want to check this part, here you say, okay, if you replace b with 68, it will be 1. So we consider 2 times 68, which is what? It's 16, 138. And look here, you can say, okay, b is 183, or if you add 136 plus the first one, or these two plus. So it will be 9, 3 plus 8, 1, we have 3. So the rest of them is bad because b we found for 251, so we should only check this one, 136, and we see we don't have any answer here. For case 3, we should check again 35b is congruent similarly. Mod 183, so if you multiply 3 times 68, so b is 3 times 68, which will be, it will be this. And if you consider mod 183, it will be 17, 21. So here you should check b is 21, or 21 plus this 4, 2 plus 8, 0. We have 1 and 2. Or the next number, we should check also this. Or if you add 183 plus this, it will be greater than the 251. 3 plus 4, 7. And 8 plus this 8. And this is 3, 8. So the rest of the numbers will be bad. So we need to only check B136, 21, and 204. Now let's copy the inequality. Okay, so let's check for the first one. B equals 136. So 136 is 136. 2019 A 35 times 136 over 183. Here you can say, okay, it's 70 times 68. And you say, okay, 0, 50 over 183. Now for the left side, we say, okay, 136 times 386, 351, 23, 1, 5, 11, 6, 8, 3, so it will be 6, 9, 1, 3, 4, 12, and then it will be 1, 3, 4, 5. Now we should divide the first one. We divide 4760 over 183. Here you place 2, it will be 6, and 16. 2 times 3, it will be 0, 1, 1, and then you place here. So here you place 6. 6 times 3, 18, we have 1. It is 10, so if you subtract, it will be 2, 0, and their difference is 2. So it's 26 point something. Now if we divide the next one, 52496 over 2019. Here again we place 2 here. It will be what? 2 times 9, 18. We have 1, 3, 0, 4. If we subtract, it will be 1, 1, 2, 1. And then we place 6 here. And if we place 6, 54, 11, we have 1, 1, this one, 2, 26 point something. So it is impossible because it is 26 point something, 26 point something. So this case is impossible. We've checked this formula for what? For when b is 136 here. Now we should check for 21 and 204. So let's copy. So let me write here, it was for B136. And now we check for 21 and then 204. For 21, if I replace here, it's 21. 21 times 35 will be 35, and 70, it will be 537, and 735 over 183. If I replace 21 here, it will be 38621, 386, 7, it's 1, and it will be 8. Now if we divide for the first one, 735 over 183. So if we replace 4, 3, 7, okay, so it's 4 point something. Now if we also check this, it will be 8106 over 2019. If I place 4 here and 40, it will be 36.3, okay, 08. And you will see, okay, we have some remainder 4 point something. So again, it is impossible. Now let's check for 204. The 204, the last case that we should check. So this one, 35 times 204 over 183, so it will be what, 35. Let's consider this one like this. You can say it's 70 times 102, so it will be it will be 7 here and 183. Now if I replace 204 for this case, then I will have 386,204. 3, 15, and 0, 2, 6, 12, 17, 7. It will be 4, 4, 7, 8, 7. Now we divide. 7140 over 183 here. 339. Start to 2. It will be 14 minus this is 5, so it's 0. 10 minus 4 is 6, and here we have 6, 165. If I place 0 here, then okay, 9, 27, 2, 7, it will be this, and we have remainder 39 point something. Now let's check this one. 78744 over 2019. If again I play 3 here, 2, 5, 0, 6, and then it will be 14, 7, 6 minus 5, 1, and then 8 minus 0, 8, and then it is 1. And then you place 4 here, and then if you write 9, 9 times 9, 81, 8, 17, 1, 1, it is this. So if we pay attention, we have remainder 3. So again, it is 39 point something, so contradiction. So all of them, we've reached contradiction, except what case? The first case that we found, a plus b equals 299. So it is the answer for the minimum b. Singapore Mathematical Olympiad SMO 2019 first round open section, problem number 17. Okay, two circles are tangent to each other internally at a point T here. Let the chord AB of the larger circle be tangent to the smaller circle at a point P. Suppose AB equals, so AB is what? Is C 59 over root 3. TA is, because here we have this, let's write still AB is this, so let's just use here 59 over square root of 3, TA equals 32, TB equals 27, find TP. So there is an important lemma that when we have, let me show you that first. I want to write two lemma and then prove this problem by the lemmas. The first one is that when you have this thing, and if we extend this, and if I call this one L, L is lemma 1, L is midpoint of arc AB, means arc AL equals arc LB. Now I want to prove this. When you have two circles that intersect or tangent internally, externally, one of the most important line that you should draw and useful in problem solving is common tangent or radical axis in general. If you don't know radical axis or anything, as I said, feel free to send message to my WhatsApp number in the description. Now, if you consider the smaller circle, this angle equals this angle. Why? Because if you extend, you can easily prove that this is equal to this isosceles triangle. So this angle equals this angle. This angle is interior angle, and it is what? It is, let me call this one alpha, alpha, alpha equals alpha. The first alpha here equals arc TBL over 2. And for this alpha, it equals interior angle TB arc TB plus AL over 2. And I can say, okay, TBL is what? Is arc TB plus arc BL over 2. All over 2, you can cancel TB from both sides. So you can, if we multiply both sides by 2, AL equals BL or LB. So we prove this. And as I said before, there are around 50 ideas, 50 formulas you should memorize. One of them is this. If dA is dA in a triangle, let me draw it in triangle ABC. Suppose dA is length of internal angle bisector through A. If I call this one BCD and it is dA, so dA squared, it has two formulas, but here we need one of them. BC minus BDDC. And you should know BDDC is what? It equals BC minus A squared, BC over B plus C squared. We want to use this formula. Lemma 2, if you want to know how we can reach this, as I said, send message to my WhatsApp number. So let's prove this part. So TP is what? By lemma 1, because if we extend this, we proved that this arc, if we draw exact figure, we proved this arc equals this arc. So T1 equals T2. So TP is internal angle bisector. So TP squared is, I've written BC. BC here is what? TA TB minus AB squared times TA TB over TA plus TB squared. Now let's replace. So TP squared equals TA 32 times TB 27 minus AB squared equals 59 squared over 3 times TA 32 times TB 27 over TA plus TB 32 plus 27 all squared. So let's calculate this. It will be 32 times 27 minus 59 squared times 32 times 27 over 3 times 32 plus 27 equals what? Equals 59 squared. So you can cancel these two things and it will be 32 times 27. 1, if you factor 1 minus 1 over 3, which equals 2 over 3. And then we can cancel the 3, it will be 9. So TP squared equals what? 32 times 2, 64 times 9. So if you consider square root, TP equals 8 times 3, which equals 24. So the answer of this problem equals 24. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 18. In triangle ABC, BC is 10, so A is 10. Let me write. CA is 9, so B is 9. Cos C is 5 over 14. The bisector of C meets the circumcircle at N that is not equal to C. It's because it intersects the circumcircle in 2 points C and N. N is not the second point. The altitude from A meets the circumcircle at L. L is not A, and NL intersects BC at M. Find the length of MC. Because we know BC is what, look, the most important thing is not to reach the best solution, because in the exam we don't know which solution is best, which solution is shorter, is easier. The most important thing is you can think logically and reach the answer. That's the most important thing. Here, we know BC, so for example, if we want to find MC, if we know the ratio, then because we know BC, MC over MB, then we can find BC. For finding ratio, one of the most important ideas is ratio lemma. If you want to know exactly ratio lemma, the proof, you could use two sign rules and then simplify. As I said, there are around 50 important ideas. If you want to know all of them, feel free to send a message to my WhatsApp number here. Now we want to use ratio lemma. It's what? We say sine n1 over sine n2. Pay attention to the thing I say. Is cm over mb. You see n1 sees what, n2 sees what? Equals mc over mb times this sine that is nearer to n1, sine c over 2 over sine what? This one, b plus c over 2. Sine b plus c over 2. So ratio lemma, if you want to know exactly, it is what? Let me explain here. You say, for example, if you have A, B, C, and if it is, for example, P, A1, A2, you say sine A1 over sine A2 equals BP over PC times sine B over sine C, or you can write, instead of sine B over sine C, B over C by sine rule. It's easily, you can prove it easily. Now, how you can prove this ratio lemma? You can use two sine rule. In triangle ABP and APC, if you write two sine rule, you can easily prove ratio lemma. Now, here I want to find the ratio MC over M. Let me write MB over MC equals sine N2 over sine N1 times sine C over 2 over sine B plus C over 2. Now here, N1 is what? N1 equals half of this arc inscribed angle equals this. This is what? Because it is altitude, it is 90 minus C. So you can say, okay, N2 is what? N2 is this angle equals this angle. It is what? Altitude 90 minus B. So sine N2 is sine 90 minus B, so it equals cos B. Sine N1 is what? Is sine this angle, sine 90 minus C, which is cosine C, times sine C over 2 times sine B plus C over 2. We know cos C is what? So we can easily find sine C over 2 and B over 2. So let's write it. MB over MC equals cos B over cos C times sine C over 2. And then you can say, okay, it is equal to sine B cos C over 2 plus, it is sine of sum of two angles, sine B cos this, cos B sine this. Cos B sine B cos C over 2 plus cos B sine C over 2. So you can take cos B in denominator of this denominator. So we have what? 1 over cos C is what? 14 over 5 times sine C over 2 over sine B over cos B tangent B times cos C over 2 plus cos B sine C over 2. So here we need to find what? Sine C over 2, cos C over 2, and tangent B. Also, we can simplify more. How? You can say that 1 plus tangent. I want to divide again denominator by sine C over 2, both of them. And then we have sine tangent sine C over 2. 1 plus tangent alpha squared is what? 1 plus sine squared alpha cos squared alpha, which equals 1 over cos squared alpha. Now, I can simplify more and say, okay, it is 1 over tangent B, tangent, cotangent. Or because it is, if you divide cos C over this, you can say, okay, it is what? Let me write cotangent, cotangent C over 2 plus 1. So we know 1 plus tangent alpha, tangent squared alpha is this. So you can find tangent and then you can find cotangent. So how? Because I want to find tangent C over 2, I say what? I say I should find at first cos C over 2. How can I find cos C over 2? I know cos C is what? Is 2 cos squared C over 2 plus, let me erase it, 2 cos C over 2 minus. So we can say, okay, cos squared C over 2 is cos C plus 1 over 2. Cos C is what here? Cos C is 5 over 14. So you can say it's 5 over 14 plus 1 over 2, which equals 28. 5 plus 14, 19. 19 over 28. And so we can conclude 1 plus tangent squared alpha equals what? 1 over cos squared C, which equals 19 over 28. So we can say it is 28 over 19. So tangent squared alpha is 2018 over 19 minus 1, which is 2019 minus 19, which is 9 over 19. So tangent alpha here means tangent C over 2. Tangent C over 2. So tangent C over 2 equals 3 over root 19. So cotangent C over 2 is reciprocal of this, which is 19 over root 19 over 3. Now we should find tangent B. If we find that tangent B, then the problem will be solved. Again, for finding tangent B, I try to find cos squared B. So if I find cos squared B, it will be okay. How I can find cos squared B? I know cos squared B equals a squared plus c squared minus b squared over 2ac. I know a is what? I know B is what? I should find C. So let me copy the assumptions here. So if I paste them, what should be? Okay. So at first I should find C, then I can find cos B. Oh, sorry, cos B is this. Then I consider consider square of cos B. So C is what? C squared is A squared plus B squared minus 2AB cos C, which equals 100 plus 81 minus 2 times 10 times 9 times 5 over 14. So I can say what? I can say it is 181 minus, I divide by 2, it will be 7 minus 450 over 7. C squared is this. So I can say, okay, it is 7, 7, 6, 5 minus 450. Now, if I subtract 7, 1, 12 minus this is 8. And I can factor, it is multiple, this number is not multiple of 3, not multiple of 5, not for 7. You can check 11, not multiple of 11 for 13. If you check 37, no. For 17, if you check, I don't think, I think we knew 19 we have here. Let's check 19. 19, if we write 19, it's multiple of 19. 4 times 19 is what? 76. We have 57, 43. So it is this. So C is 19. Okay, so C equals square root of 19 times 43 over 7. Now that we found C, we want to find cos B. Cos B is what? A squared 100 plus C squared 19 times 43 over 7 minus B squared, which is 81 over 2 times A times C. 2 times 10 times C, which is 19 times 43 over 7. Now, if I consider this part, I can factor, it is 19, 100 minus 81. You can factor from 90, it will be 1 plus 43 over 7, which will be 50 over 7. Then I can write 2 times 10 times 19 times 43 over 7. If I simplify, I can say, okay, 0, 0. And then you have 7 here, root 7, and 19 here, root 19. So it will be root 19 times 5 over 2. Root 19 will be cancelled here. Root 43. And root 7, here 7, root 7 we have. So we found cos B equals this number. Okay, now we can find, let's see here. We want to find tangent B. 1 plus tangent squared B is 1 over cos squared B, which equals 4 times 43 times 7 over 25 times 19. So we can say tangent squared B equals 4 times 43 times 7 over 25 times 19 minus 1. So let's find this part. Control C. I found cotangent. Let me at first paste it here. Okay, so, and also I found cotangent. C is what? Let me paste this one here. So I want to find what here? I want to find tangent B. So if I simplify this part, let me write with flag. 4 times 43 is what? 172. So 7 times that, this. Minus 25 times this. So 25 times 20 is what? Is 500. So it will be minus 25. It will be this over 25 times 19. And now this part. 14 minus 5 is 9. And then you say 9 minus 7 is 2. And here 1. 11 minus 4 is 7. 7 to 9 is 3 to the power of 6. So if we want to find tangent B, we consider a square root. It will be 3 to the power of 327 over 5 root 19. Now, if we replace here, it's 14 over 5 times 1 over tangent B is 27. If I multiply these two things, root 9 will be cancelled. 27 and 3. Then we have 9. 9 here over 5 plus 1. So it equals 14 over 5 times 5 here. 5 plus 9, 14. So it will be 1. So we proved what? This is 1. Now here, if you say, okay, it is 1, it means MB equals MC. Because MB equals MC, so you can conclude what? M is the midpoint. BCA is 10, so MC is half of that, which equals 5. So the answer equals 5. Singapore Mathematical Olympiad 2019, SMO first round open section problem number 19. Let x1 be the only real root of log x in base 2 equals 22, 20 minus x, and x2 be the only real roots of 2 to the power of x equals 20 minus x. Determine the value of x1 plus x2. Okay, so x1 is the only roots of this, so you say log x1 in base 2 equals 20 minus x1, and also 2 to the power of x2. x2 is the only real root of this, 20 minus x2. So if you consider log, then we can if we consider log of this number, log of, let me write like this, 2 to the power of x2 in base 2 equals log of 20 minus x2 in base 2, because we know left hand side is not negative, so right hand side is also not negative, so it is the only root of this one. And x2 will be, let me show you the log is what, for example, log of x in base 2. So it will be this function, a strictly ascending function here. So you can say the only roots of this is x2. You can conclude, because it's strictly ascending. Now you can conclude x2 equals log 20 minus x2 in base 2, because these two functions are exactly equal. If I consider this one z, then you can conclude log z in base 2 equals 20 minus z, because x2, when 20 minus x2 is z, so x2 equals 20 minus z. From here, the problem says x is the only real roots of this equation, so we conclude that z equals, this one equals x1. Z is what? Z is 20 minus x2 equals x1, so we conclude 20 equals x1 plus x2. The problem says what? Determine the value of x1 plus x2, so the answer equals 20. Singapore Mathematical Olympiad, SMO 2019 first round open section, problem number 20. Determine the minimum integer x such that the following inequality holds, this term greater than 0. Okay, if you pay attention to this term, it is strictly ascending, because if you increase x, it will be increased, here will be increased, and also here will be increased. So we should find the minimum x. We can check some number. For example, if you replace x with 0, then you have, okay, 0, negative 500. So you should increase, or let me call this one a. If x is 0, then a will be what? It will be negative 200, cube root of negative 200 plus cube root of negative 300, and from negative 500, we know it's negative. So you should consider some x that they will be positive. For example, if you consider x20, if x equals 20, so the first one will be 0, here will be negative, also here will be negative. Okay, so for 20, you have 0 and plus a negative number. This term will also be negative. So again, bad. If you consider x 30 here, it will be 0. It will be positive. So for example, if x equals 30, then you have what? Cube root of 300 minus 200, 100. Here 0 plus 100. We know it is positive here. So the answer is between 20 and 30. So we found root here. For example, let's check when it equals 0. If x equals 25, so it will be what? It will be cube root of 50 plus cube root of negative 50 plus 500 minus 500, which equals 0. So that's exactly the boundary between negative and positive. So we understand that if x equals 26, it's the minimum number, that this term will be greater than 0, because it is strictly ascending. If you had any question about this solution or the other solutions, as I said, feel free to send a message to my WhatsApp number in the description and also here. Singapore Mathematical Olympiad SMO 2019 first round, open section, problem number 21. Let S equals limit of this sigma when n approaches infinity. Find floor of S. Okay, so let's consider this one an. We want to find an at first. An equals what? E to the power of 1 over n plus e to the power of 2 over n plus e to the power of n over n all over n. We define r equals e to the power of 1 over n. It will be r plus r squared plus r cubed plus to r to the power of n and all over n. So if we want to use this identity, we will write r over n1 plus r squared plus r to the power of n minus 1. You should memorize this identity, and there are around 5 identities and also some other things. If you want to know them completely, as I said before, feel free to send message to my WhatsApp number here and in the description. So let's write an equals what? R over n times rn minus 1 over r minus 1. Now, we want to calculate this when n approaches infinity. So it equals what? R equals e to the power of 1 over n. Let's write r minus 1 here. So I can write times rn minus 1. Rn minus 1 will be e minus 1 and times 1 over n times r minus 1. So if we consider s when n approaches infinity, positive infinity, it will be 1 e to the power of 0. It will be e minus 1. So times 1 n times r minus 1. So it equals e minus 1 times limit of when n approaches infinity. 1 over n times r minus 1. We replace r with e to the power of 1 over n minus 1. So we should calculate this limit. Okay, now we solve rest of this problem by 2 solutions. Let me tell you. I want to calculate this. Let me consider it is, for example, b. So b is what? I consider 1 over n equals t. So it will be what? Limit of n approaches to infinity means t approaches to 0. T over e to the power of t minus 1. So solution number 1, because it is 0 over 0, e to the power of 0 minus 1 will be 0. You can use L'Hopital's rule. So if I write, it will be L'Hopital's rule. I differentiate from both numerator and denominator. It will be b equals limit of t to 0, 1 over e to the power of t. It will be 1 over 1, which equals 1. Solution 2, if you want to solve it, you can say, okay, b equals limit when t approaches to 0, t over e to the power of t. We know it equals 1 plus t over 1. It is important, memorize that t over t squared over 2 factorial, t3 over 3 factorial for real number t. If we replace it here, we will have t over 1 factorial, t squared over 2 factorial, and so on, because t approaches to 0. So you can ignore from t squared over 2 factorial, rest of that. It will be t over 2, it will be 1. So with these 2 solutions, I found b. So s is what? S is e minus 1 times b, which b equals 1. So it equals e minus b. So we found b, and the problem says, okay, we'll find floor of s. We know e is less than 2.72. So it will be floor of 172, and we know it is greater than 2.71. So it is, we can say it will be around e minus 1. E minus 1 will be less than 172 and greater than 171. So floor of e minus 1 equals 1. Singapore Mathematical Olympiad SMO 2019 first round, problem number 22. 2 points A and B are randomly selected on a line segment OC. The probability that the segments OA, AB, and BC form the sides of a triangle is P. Find the value of floor of 1 over P. Note, if you think the answer of P is 0, enter your answer as 99,999. Okay, if we consider line OC without loss of generality, we consider that OC equals 1, because you should check triangles inequality. For example, let me tell you OB, OC here, it is A, it is B. If we should check, for example, this length plus this length, triangles inequality greater than this length. So if we consider OC1 and then for any OC, for example, length L, you multiply the triangles inequality by L and it is equivalent. So without loss of generality, we consider that length of OC equals 1. Now, we consider OA is x, BC is y, 1 minus x minus y. So in this case, we have this. Let me call this one case 1. And in case 2, case 1A is left, B is right. In case 2, it's what? In case 2, we have, let me correct it. Okay, Control C, Control V. In this case, we consider A is right side of B. Here, B. So, OA here, it's X. OB here, CB here is, because the problem says BC, AB. It is Y in this case, and this part will be X plus Y minus 1. Now, we want to, we say, okay, X and Y are what? 1 to 1. So because we have two variables, we draw on plane. So it will be something like this. We want to see what X's and Y's are good. So it is for both of them. You consider one here, one here. And if I draw this part, it will be, if I want to draw this part exactly, it will be something like this. So the whole area is what? The whole area is 1, so you should find the good areas. Now, here we should write 3 inequalities. X plus 1 minus x minus y. At first, x plus y here is what is less than or equal 1. So we are working on this area. Because this line is x plus y equals 1. So here, and in this case, x plus y is greater than or equal 1. X plus y, you can say, for example, it is strictly greater than 1, greater than or equal 1. It's not important. So x plus y, x plus 1 minus x minus y should be greater than y. So if we cancel 1 greater than 2y, so y is less than 1 half. So if you check the next one, x is less than 1 half. Similarly, if you check y plus this. And the last inequality we should check, let me move it here. The last inequality is what? X plus y should be greater than 1 minus x minus y. So it's equivalent that x plus y is greater than 1 half. So here, if you want to check that, it will be what? It will be 1 half here, 1 half here. And then we say, okay, it is 1 half, for example. It is 1 half. X less than 1 half, y less than 1 half, and x plus y greater than 1 half, some of them. So this area is good for the first case. Now let's consider second case. In second case, x plus y minus 1 is greater than y. It is equivalent. You cancel y from both sides. X greater than 1 half. Similarly, it is equivalent for y greater than 1 half. And the last part is x plus y greater than equal x plus y minus 1. So here we can say what? We say it is equivalent that x1 greater than 0, and we know that it is obvious. So here, if we want to draw it, x will be greater than 1 half. 1 half, if you draw it in this area, x greater than 1 half, y greater than 1 half will be this area. Now, you should add up these two areas and divide it by 1, the whole area. So P, the probability, is what? This area is 1 over 2 times 1 over 2 over 2. This area is 1 over 2 times 1 over 2 over the whole area of 1. The first one is 1 over 8. The second one is 1 over 4. If you use common denominator, 3 over 8. But the problem says consider floor of 1 over p. So 1 over p is 8 over 3 is 2 point something. So if you consider floor of 1 over p, it equals to. So the answer equals to. Singapore Mathematical Olympiad SMO 2019 first round open section problem number 23. Find the largest positive integer k such that 3 to the power of k is a factor of the value of the following expression. 2019 factorial squared plus 2019 factorial to the power of 4 plus 2019 factorial to the power of 6 plus 2 plus 2019 factorial to the power of 2020. Okay, so let's solve this problem. Here, at first I want to find V3 of 20 factorial. First, I want to find this. V3 means what? V3 means maximum power of 3 in 2019 factorial. For example, V3 of 12 is 1 because the power of 3 that divides 12 maximum power is 1. V3 of 4 is 0 because 3 doesn't divide. V3 of, for example, 18 is 2 because 3 to the power of 2, the maximum power that divides 18. Now I want to find this. There is an important formula that it equals 2019 floor of 2019 over 3 plus 2019 over 9 plus 2019 over 27. Let me tell you an important formula, an important way how to solve it quickly. So you do like this. You say 2019 over 3. It will be what? 6, 21, 7, 3. Then you divide it by 3 again. 2, 2, 4. Then you divide it by 3 again. It will be 7, 14, 4. Then you divide it again by 3. It will be 2, 4. You divide it again by 3, 8. And by 3, 2. So you can't divide anymore. Now you should add up 2, 8, 2, 6, 7, 3, which is here. So it's just increase your speed. If you want to know other ideas, other solutions, any important thing, or wanted more explanation, as I said, feel free to send message to my WhatsApp number here and in the description. Now here it will be 673 plus 224 plus 74 plus 24 plus 8 plus 2. Now it will be 10, it will be 34, it will be 108. Here it's 7, 9, 8. And if you add up 15, 10, 1, we have 9, 10. 1005. So V3 of 2019 factorial to the power of 2 which equals 2 times 1005 because it is 2019 factorial times 2019 factorial. It will be 3 to the power of this times 3 to the power of this will be 3 to the power of 1005 plus 1005, which equals 2010. Now we can say what? The first one, 2019, let me write this expression. Copy. So the first one is what? 3 to the power of 2010 times, for example, k1, with which k1 doesn't, 3 doesn't divide k1. The next one, it will be 3 to the power of what? 4 times 1005, k, for example, 2, plus the other numbers. You can say, you can factor from 3 to the power of 2010. K1, we know 3 doesn't divide K1 because maximum power of 3 that divides 2019 factorial squared is 3 to the power of 2010. It will be K1 plus all of them will be, if you factor from 3 to the power of 2010, it will be 3 to times K prime. Now, if you want to check, for example, it is A. If you want to find V3 of A, it equals V3 of 3 doesn't divide this because 3 doesn't divide K1. So it will be equal to 2010. So the answer of this problem equals 2010. International Mathematical Olympiad SMO 2019 first round, open section problem number 24. Let S equals 2i minus 1i equals from 1 to 2019. Determine the minimum value of k where k is a positive integer such that for any subset A of S with the number of elements in A greater than equal k, A contains two numbers A and B with the property that B equals 3 to the power of SA for some integer S greater than equal 1. Okay, here, if I write the numbers in S, then they will be I1, 1, I2, 3 odd numbers, 5, 7 to the last number. Last number 2 times 2019 is 40, 38 minus 1, 40, 37. So the previous number will be 40, 35, and the previous number will be 40, 33. Now S is this minimum. We want to find minimum value of k where k is a positive integer such that for any subset A, the number greater than or equal A contains two numbers A and B such that. Now, I want to define B with maximum number such that there is no, it means there is no this sign. There is no A and B that B equals 3SA, that S is greater than or equal 1. If I find B, if I maximize B, then the number of elements in A will be B plus 1. Let me explain more. So here, look, the numbers that are related, 1, 3, 9, 27, and so on. The next one, we don't have 2, 5, 5 times 3, 15, then 3 times is 45, the next one is 21, 7, 21, and so on, 63, for example, next number. So we guess if we want to find B, we want to see that what's the maximum number that we can select that we don't see any of these. Then if the number of A is 1 more than that, then we are sure that A contains 2. It says minimum number of elements in A such that minimum k, such that if a number of A is greater than or equal k, we are sure that A contains two number A and B. So we want to maximize B that doesn't have this property. So we say, okay, from the first part, we can select at most 1. From second part, we can select at most 1. From third part, we can select at most 1. We guess that maybe the answer is the number of primes. No, the number of prime numbers, for example, from 1 to 47, we should check. But if you check, for example, 9, 7, 8, 9, 10, 11, you check 11, 33, 13, then you check 15, 15 we have here, 17, 19, 21, you've selected here, 23, 25. So we see that we shouldn't consider the only prime numbers. If you pay attention, if we cancel all multiples of 3, for example, it is 25 and so on. If you reject all of them, from each subset we can select at most 1. So if we consider the first element, the smallest element in each subset, in each part, then all of them are good, and that's the answer for B when it has maximum number of elements. So we should say the answer for B, we want to maximize, maximum of B equals all numbers here. How many numbers do we have? 2019. 2019 minus the number of elements in A that 3 divides A. So we should calculate this. So because A is in S, so we know A mod 2 is 1. And 3 divides A, so A mod 3 is 0. Now we can say that it is equivalent, this part. She can find it is mod 6 is what by Chinese remainder theorem, and you can easily check. 0 doesn't satisfy, 0 plus 3, 3 satisfies. If you want to learn solving these things for also larger number, wanted more explanation, as I said, feel free, send message to my WhatsApp number here and also in the description. A is congruent to 3 mod 6. So we should find this. A equals 6k plus 3. 6k plus 3 greater than equal 1, less than or equal what? Less than or equal 4037. 4037. So you say, okay, 6k greater than equal minus 3 minus 3 minus 3, 4034. When we divide by k and consider for here floor seal of that, and for here floor of that, because k is integer, then let's see what we have. K will be greater than equal 0, less than or equal 6, 36, 43, 7, 14, 2 point something. So k is greater than equal 0, less than or equal 6, 7, 2. So the answer of this problem will be 2019 minus 673. Here it will be 6. 7 minus 11 is 4. And 6 minus 9 is 3, 1. But look, here was let me call this one not the last answer. It was maximum B. We said, okay, if B can have 1346 elements, that doesn't satisfy the condition. So K will be 1346 plus 1 to satisfy the condition. We are sure then that A satisfies the condition of the problem. So the answer, last answer of this problem equals 1347. Singapore Mathematical Olympiad SMO 2019, first round, open section problem number 25. Allame is going to fill in each cell of a 7 by 14 table with one of the 4 letters SIMO so that in each 2 by 2 block exactly one of the 4 letters is used. Determine the number of ways that this can be done. For solving this problem, we want to use one idea that I can say it's the strongest idea that's useful in high level like IMO and round 2 national levels. The idea is what? Considering a small example. In this problem, it's easy to use that, but in some problems, you can use a small example from different aspects. Here, I say, okay, we start from 2 by 2. Then we have 2 by 2 table, so SIMO, you should place it will be 4 factorial. Now let's consider 2 by 3. Then you say, okay. Here, for example, without, you say 4 factorial for the 2 by 2 without loss of generality. Suppose this is SMO like this. These two tables must be S or M, SM, MS times 2. And then you can generalize the idea, and if you have 2 by n, 1n, you say 4 factorial, and then 2 to the power of n minus 2, like this. Now, but here we can't generalize the idea, so we should check 3 by 3, and with checking 3 by 3, we can find the idea, and then we prove. If we check 3 by 3, here the first one without loss of generality, it will be SMO. Like this, and you multiply by 4 factorial. Then this one is SM or MS. So you have 2 cases. In the first one, you say SMIO. If it is SM, let me write the rest of that by black. SMMS. Now here for this part, you can say, okay, we have SI, so there are two cases, SIS or ISI. But for here, you should place here what? Because it is SI, here SI. Here it is MI, it is MI. But if you want to place SI, IS is impossible because we have S here, so you should place SI and also M here. So one case, it will be 4 factorial 2 plus 1. So we guess what? We guess for 3 by n. If I want to check, for example, let's also check 3 by 4 to understand completely. We want to solve it with what idea? SIMO. So here for this one we have SM, and for the next one IO. So if I copy, we have 4 cases to consider. Control V. Let me minimize a little. This one, minimize a little more. And also minimize this part. This part. And the last part here. Okay, we guess that if you have SIS, all of them SM, 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 and IO, 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 then for this one we have 2 cases. For other case we have more other rows, we have 1 case. So let's see, is it correct or not? It's our claim so far. So the first one is SMIO. The next one is SM but OI. The next one MSIO. And the last one MSOI. For this one, it is obvious SISI or ISIS. You can say do, and you multiply all of them by 4 factorial. Here, you should select SI here and IS here. So, because it is ISIS, you can't place I here, so you should place I here. So, because it is S, the other one will be unique. It will be S here, and it will be O here, and that's okay. Here, SM, it is the first part. So SI, you can't place S here, so it will be I, and it will be S here. Sorry, it will be S here and I here because SIS is impossible because of this 2 by 2 block. So it will be MI, and the rest of that is unique. For this part, you say, okay, SI, again, you can't place S here, S is here, I is here, M is here, O is here. And that will be okay. So here we say, okay, the answer is 4 factorial 2 plus 1 plus 1 plus 1. Now, suppose that we are in the exam. At first, we guess the answer of the problem by this idea is what we generalize our claim, and then we try to prove this. 2 plus 3, 5. 4 factorial times 5 is 4 factorial is 24. 24 times 5 is 5 factorial 120. Now, the problem says what? Our table is for 7 by 14. So we consider this part, this part, this part, this. At first, we say, okay, here it's 4 factorial without loss of generality. Suppose it is 4 factorial times. Now, for other cases like these 2 cells, we know it is 1, 2, 2, last part. Is 7, it is 1, 2, 14. So you say what? 4 factorial 2 to the power of 12. But if you consider 2 to the power of 12, only the case that it is SMIO, all of them are same. So let me subtract that case. In that case, this will be times 2. So here we have 2 cases for these 2 cases. 2 to the power of 5 plus sorry. Here it will be unique because we don't consider all the cases except SMIO. We consider the rest of them will be unique, like these 3 cases here. These 3 cases here. So like here, you say, okay, we have 4 factorial times for these two columns here, we have 2 squared, except this one, minus 1 times 1. All of them are unique. But for this case, the first one, the next row, the third row, we have 2 cases. And here, because we have from 3 to 7, it will be plus 2 to the power of what? 2 to the power of 5. So if we calculate this, it will be 24 times 2 to the 12 is 4096 minus 14095 plus 32. It equals 24 times 7, 12, 14127. If we multiply 24, 4127, it will be 28. We have 2. 4 times 2, 8 plus 2, 10. 1. 4 times 1, 4 plus 1, 5. 4 times 4, 16. 2 times 7, 14. We have 1. 2 times 2, 4 plus 1, 5. 2 times 1, 2. And 2 times 4 is 8. So if we calculate, it will be 0, 9, and 9. So the answer equals 99,048. We found the answer. Now we want to prove. If we want to prove, let me copy this one for general m by n. Let's see, the answer should be what? So by our way, we say, okay, it is, for example, m by n table. The answer, we want to generalize and prove it for general n by n table. It will be 4 factorial here 2 to the power of n minus 2 minus 1 times 1, the case that all of them are not SMIO. Then the other rows will be unique, plus 1, the case that it is SMIO. Then third case has 2 case, this 2 case, third row, 2 cases, times 2 to the power of m minus 2. So answer for m by n, our claim is this. We want to prove that. For this case, 1 times 2m minus 2, it is the case that, let me copy this one again. Control C. So let's at first prove this, that it is 1 times 2m minus 2. If I draw more columns, so all of them are what? If you consider them, all of them are SMIO, SM, and the last one. Here, for example, it is not important. It is without loss of generality. Suppose SI, and this one MO. So if you consider the first row is only SI, the second row only MO, so this is only S and I. So if the first one is S, then the next one, for example, it is S, or IS, for example, IS. All of them will be like this. And here it will be IS. And again, for fourth row, because we know only SI we have, then it can be, for example, MO or OM. For example, I place here MO, and here it will be MO. So each row, for example, this row, the third row, the odd rows have only I and S. So if it starts with I, then we have IS. The rest of that is unique. So here you should only consider these cells, that it must be what? 2 to the m minus 2. This one is obvious. Now we should prove the first term. For this term, let me again paste the table. Let me tell you, it happens what? When we don't have like these two cases, SISO, the third case is exactly the first case. We want to prove this. The third case is exactly, third row is exactly first row, fourth row is exactly second row, and like this, from third row, all of them will be unique. Now, for this case, again, if I draw more columns, So let me write like this. Suppose, for example, we have SI, SMIO, SMIO. You can say, for example, for you reach until ith column. So I here explain only for MS here to understand better. If you want to learn how to write these things in general for national level, for IMO, as I said, feel free to send message to my WhatsApp number in the description. Now, suppose it's the first time that the order changed. For example, SM, IO, IO, SM. If we have MS or, for example, SM, then OI. Without loss of generality, suppose it is MS. Now, you say what? You say, okay, here we know that it must be one of them is S because of this. One of them is S, one of them is I. Because here it cannot be S because of this 2 by 2. So it will be I, it will be S. Now the rest of that will be unique. Why? Because I am here, I, we have M. So here and also S, I. So this third row will be exactly first row. Now for second row, we use exactly this column that for the first time it has been changed. So you say, okay, MS because it is not SM. So here again, it is MS, it is SM. So you say what again? You say, okay, if I consider these two cells, there are MO. M cannot be here because of these 2 by 2. So it will be what? M is here, O is here. And then the rest of that will be unique OM, and here the rest of that is. So second row is the fourth row is exactly equal to second row. So all similarly, fifth row is exactly to third row. So all odd rows are exactly first row equal to first row, and all even rows equal exactly second row. So we proved it is unique. How many cases did we have? 2 to the n minus 2, all cases except 1. This minus 1 times the other one will be unique. So we found the general answer equals this. So we solved this problem for general n by n table like round 2 problems.